So last time we covered about electric field intensity and we derived the expressions for electric field intensity due to line charge and surface charge. Okay, so I'll just list down it here so that we can use them in numerical. So electric field due to line charge is given as, what was it? It was rho L by 2 pi epsilon 0 rho, it can be epsilon also, into a rho cap. So I'll just multiply and divide by 2. Why, I will tell you in some time. So 2 rho L by 4 pi epsilon rho a rho cap. So why we write in terms of 4 pi epsilon is because the term 1 upon 4 pi epsilon we know already. What is it? 9 into 10 raised to 9 Newton meter square per coulomb square. That's why we multiply and divide by 2 so that calculations become simpler. Then we have electric field due to surface charge. What is it? Rho s by 2 epsilon az cap. Now it depends, az cap depending on where the surface charge is oriented. So if the surface charge is oriented along the z plane, I mean in this way, so this is x, y, z, right? So which is z plane? Z plane means xy plane. So it is along this direction. So it is along xy, that xy plane, that is z plane. So we get az cap. So in the same way, if it is along x plane, so this is x, y, z. So x plane, let's say it is at x equal to 2 plane. X equal to 2 plane. So this is 2, let's say. So this corresponds to x equal to 2 at this point. It is going through this point. So it is at x equal to 2 plane. So we will get rho s by 2 epsilon ax cap. Now next question is whether it will be plus ax cap or minus ax cap, because direction is also important. Now this is the x equal to 2 plane, right? So if you have to find the electric field at, let's say, minus 1, 2, 3. So if you observe x is minus 1, right? So where will be minus 1? Behind this plane, right? So direction is what? Minus ax cap, because the vector will point inside the paper. If it is, let's say, 4, 5, 6, where is it? It is ahead of this x equal to 2 plane. So vector will point towards the camera, right? Or towards you. So the vector is in which direction? Plus x cap. In that case, it will be plus x cap. These things you have to note down. You don't have to buy it, you have to note them down. Note them down in the sense you have to remember you have to understand the concept. So let's start with the numericals. So what is given? An infinite uniform line charge with density of 20 nanocoulomb per meter is located along z-axis, and surface charge density of 0.1 nanocoulomb per meter square exists on plane z equal to 3, and we have to find E vector at 1 to 5. So obviously what we will need first? The coordinate system. So let's draw the coordinate system. So this is x, this is y, this is z, right? So what do we have to do? Uniform line charge density 20 nanocoulomb per meter. Where is it located? Along the z axis. So this is my z axis, right? So I'll use a green pen. So this is my line charge. What is its value? 20 nanocoulomb per meter is located along z axis. We'll talk about surface charge density later. And it exists. Okay. Find E vector at 1 to 5. So 1, y axis is 2, z is 5. So let's say it is point P. So P of 1 to 5. Right? Now what we know, where is the line charge located along z axis? So this is the z axis. So we don't know since it is infinite, we don't know any z coordinate, but we know the x and y coordinates. What are those? 0, 0. So we know on the entire line charge x coordinate is 0 and y coordinate, that is also called as ordinate, is what? 0. So we only need the z coordinate, right? So for that what we do, this is the usual procedure, standard operating procedure followed for numericals on line charge. So make sure you understand this. We take the point where we have to find the line charge, that is point P, and drop a perpendicular towards the line charge. So I go like this. So if you observe what is happening, I am moving along the y axis, right? So what is happening on this axis? Is z changing? No, z is not changing. So what is the value of z? 5 here. So here also it will be 5. And as I told you, we already know x and y. What are those? Since placed along z axis, x and y is 0. So what is it? let's say it is point Q, so 0, 0, 5, right? And what we have to do, we have to find electric field at this point. So at this point means vector will point here, so which vector we have to find? QP vector. So what is QP vector? P vector minus Q vector. So P minus Q, so 1 minus 0 is 1, that is I cap. 2 minus 0, again 2 j cap, and 5 minus 5 0. So for line charge you will always get either I cap, j cap, k cap, or I cap, k cap. Only two of the vectors you will get, not all the three vectors, right? So let's try the formula for line charge. So electric field due to line charge is 2 rho L by 4 pi epsilon rho aero cap. So what is rho? This distance is nothing but rho. So rho is what? Magnitude of QP vector. So it will be square root of 1 square plus 2 square. So 4 plus 1, 5. So therefore rho equal to square root of 5 meters. Here it is given meters. Then we require aero cap also. So aero cap will be what? QP vector upon magnitude of QP vector. So I cap plus 2 j cap upon root 5. Right? So let's calculate electric field due to line charge. So equal to 2 into rho L is given 20 nanocoulomb per meter. So 20 nano 1 upon 4 pi epsilon is 9 into 10 raised to 9 upon rho. Upon rho is root 5 into aero cap. So I cap plus 2 j cap upon root 5. Right? So let's find this. So again this quantity is common, the one marked with green color. So let's calculate that in calci. So 2 into 20 into 10 raised to minus 9 into 9 into 10 raised to 9 divided by root 5 into root 5 is 5. So 72. So what we get is electric field due to line charge equal to 72 times I cap plus 2 j cap. So I cap plus 2 j cap. So you just multiply this to get the final answer. So electric field due to line charge will be 72 I cap plus 2 times 72 is 144 j cap. What is the unit? Volts per meter. Again you can write newtons per coulombs also. Force per unit charge. Right? So this is electric field due to line charge. Then what we have to find? Surface charge is given. So electric field due to surface charge also we have to find. So let's draw the coordinate system again. This is up to you. If you want, you can use the same coordinate system which you have used here. I am using a new one. So surface charge density 0.1 nanocoulomb per meter square exists on plane z equal to 3. Z equal to 3 means which plane? XY plane. Right? So let me use a green pen. So it is this plane. So x is changing, y is changing. What is the value of z? 3. Right? So I should have drawn it a bit upwards. Right? So it is fine. So let's say this is that z equal to 3. Right? So z equal to 3. This is 0.1 nanocoulomb per meter square at z equal to 3. Next, what we have to do? We have to find E vector at 1 to 5. So 1, 2, 5 will be above this plane. So somewhere over here. So again P of 1, 2, 5. Right? So what is the formula? Electric field due to surface charge equal to rho s by 2 epsilon A. What will it be? Since it is along z axis, so it will be az cap. So we have to see it is plus or minus. Right? So z equal to 3 is here. We are finding above that. Why above that? Because 5 is greater than 3. So it is above. So it will be plus only. So now just substitute the formula. Simple, you will get the answer. So rho s is 0.1 nano upon 2 into epsilon is what? As I told in one of the lectures, epsilon 0 into epsilon r. Epsilon r is not given, so assume it to be 1. For that it is given as what? It is not given, so assume it as 1. So epsilon 0 is 8.85 into 10 raised to minus 12 az cap. So therefore electric field due to surface charge equal to 0.1 into 10 raised to minus 9 divided by 2 into 8.85 into 10 raised to minus 12. 5.65. So 5.65 is Z cap volts per meter, right? So this is electric field due to line charge and surface charge. So what will be the total electric field? It will be the addition of these two, right? So I'll write here. So therefore, you have to write in the exam. Therefore, the total electric field is given as E vector equal to electric field due to line charge plus electric field due to surface charge. Therefore, electric field equal to, what was due to line charge? I cap, J cap plus K cap. So here I have used J cap, so here also I'll use K cap. It should be consistent. So 72, 144, and it was 5.65, I suppose. Yes, plus 5.65 K cap volts per meter. So this is our final answer. So this question you can expect in the exam for 10 marks. Okay, quite simple. Only thing what you have to remember, for line charge, drop a perpendicular from the point where you have to find the electric field to the line charge. Okay, and you will always be having 2 points. In this case, the points are not given directly. They have mentioned that it is along z axis. So along z axis means x and y is 0. This way 2 points will be given. Third point will always be from the point where you have to find the electric field. Okay, so let's see one more example so that it is clear. So now a sheet charge rho is equal to 2 nanocoulomb per meter square located at x equal to 2 in free space, and line charge rho L equal to 20 nanocoulomb per meter is located at x equal to 1, z equal to 4. So again, see, for line charge 2 points are given. Find electric field at origin and direction of electric field at 4, 5, 6. You don't have to worry about what direction now. Whenever they ask electric field, it is always a vector. So you have to find a vector only. So in this case, both the questions are same. Find electric field at origin and at 4, 5, 6. Okay. So let's first do surface charge because it is simple. So let's draw the coordinate system first. So x, y, z. So it is located at x equal to 2, means yz plane. So yz plane is this and x equal to 2. So let's say this is x equal to 2. So like this. So y is changing and z is changing. So this is 2 nanocoulomb per meter square at x equal to 2, right? And where we have to find at origin. So let's say first at O of 0, 0, 0. So where is the origin? Behind this, because it is x equal to 2. This is x equal to 0. So what will be the electric field due to surface charge? Rho s by 2 epsilon. It is at x. So ax cap. And since it is behind, so for that behind we incorporate the negative sign. So rho s is what? 2 nano by 2 into 8.85 into 10 raised to minus 12 minus ax cap. So you can find this electric field due to surface charge equal to. Okay. So let's find that 2 into 10 raised to minus 9 divided by 2 into 8.85 into 10 raised to minus 12 into minus 1 for this minus. So minus 112.994. So I can write minus 113 ax cap volts per meter. Right? Then second at 4, 5, 6. Right? So again, electric field due to surface charge equal to, so rho s by 2 epsilon, let's say x, let's say not, it is x cap only. So where it is at 4, 5, 6, so it is ahead because this is x equal to 2, this is x equal to 4, so it is ahead, so plus x cap. So again, so 2 nano upon 2 into 8.85 into 10 raised to minus 12 x cap, right? So this is equal to, I'll use the previous things. I think the values will be same, right? So it is the same thing but plus. So 113 x cap volts per meter. So now let's find due to line charge. So electric field due to line charge. So again draw the coordinates, very important. So x, y, z. So what is given? Line charge is rho L equal to 20 nanocoulomb per meter, x equal to 1, z equal to 4. So how to draw this? Let's see, x equal to 1, so somewhere over here. Z is 4, so somewhere over here, right? And y we don't know, so y is this line. Since it is a line charge, it should resemble a line, right? So this is my line. So what is it? X equal to 1, z equal to 4, right? And we have to find that 4, 5, 6, our first origin. So at origin, so this is my point O, right? So what will we do? We'll drop a perpendicular, right, like this. So if I drop a perpendicular like this, it will be along this axis only, right? So what will be the coordinate? I know x equal to 1, z equal to 4. So x is 1, z is 4. I don't know this. What will this be? Since this here y coordinate is 0, this is just getting upwards, because on this point y is not changing, so this will be 0. So let's say this is point A, and where I am finding the electric field at origin, so it will point like this. So I have to find AO vector. Again I have to find electric field at origin, so the vector will point downwards. So AO vector is O vector minus A vector, so minus I cap minus 4 k cap. As we saw in the previous numerical, we get only two of the vectors, right? So this is AO vector. Then we also require rho. Rho we saw it is magnitude of the vector we find. So square root of 1 square plus 4 square. So therefore rho equal to root of 17 meters. Then what we require? Aero cap. So aero cap is minus I cap minus 4 k cap upon what is it? Root 17. Okay. So root 17. Yeah. So electric field due to line charge equal to, what is it? 2 rho L by 4 pi epsilon rho aero cap. What is rho L given as 20 nanocoulomb per meter. So 2 into 20 nano upon 4 pi epsilon is 9 into 10 raised to 9 upon rho. Rho we got as root 17 into minus I cap minus 4 k cap upon root 70. So therefore electric field due to line charge equal to, so now we just have to calculate. So 2 into 20, that is 20 nano, right? So this nano is what? 10 raised to minus 9, and this is 10 raised to 9, so that will get cancelled. So I will not use. Into 9 divided by, last time we used root into root, so same way upon 17. So 21.177 times minus I cap minus 4 k cap. So therefore electric field due to line charge equal to minus 21.177 I cap, and this into 4 minus 84.71 k cap volts per meter, right? So at origin, so we can say therefore at origin total E vector equal to E vector due to line charge plus E vector due to surface charge. Therefore E vector equal to, so at origin we have found out minus 113 Ax cap, and this is I cap. So this should be, make this either I cap or make this Ax cap, A by cap, Az cap. Make sure you are consistent. For me it is fine, I am not getting marks. So minus 113 minus 113 minus 21.177, so minus 134.177 I cap. And that's it, we have only I cap, so this will be same, minus 84.71 k cap volts per meter. This is final answer for origin. Similarly we have to do for what? 4, 5, 6, right? So again we'll require the coordinate system. So x, y, z. So again, where is the line charge located? X equal to 1, z equal to 4. So as we saw last time, it will be like this. On this point, each and every point x is 1 and z is 4. And y is changing. So we have to find y. And we have to find electric field at 4, 5, 6. So x is 4, y is 5, z is 6. So now you have to check whether it is above or below. What is z for the line charge? It is z equal to 4. So it will go above. So P of 4, 5, 6. Right? So what will we do? We'll drop a perpendicular on this. Right? So this we know x is 1, z is 4. So y coordinate will come from here. So it is what? 5. So 1, 5, 4. So let's say this is Q. And we have to find electric field at P. So it is vector is pointing upwards. So it will be QP vector. Right? So you can find QP vector. I am not solving this. Then you have to find rho. What will be rho? Magnitude of QP vector. And A rho cap will be what? QP vector upon magnitude of QP vector. Right? Then electric field due to line charge, what is it? 2 rho L by 4 pi epsilon rho A rho cap. You have A rho cap, you have rho. 1 upon 4 pi epsilon is 9 into 10 raised to 9. What is rho L? Rho L is 20 nanocoulomb per meter. So rho L is given here. Right? So you can solve this. So solve this. What you will get? You will get electric field due to line charge. Then you will say at 4, 5, 6. Total E vector is E vector equal to E vector due to line charge plus E vector due to surface charge. So therefore E vector equal to whatever is the answer with the units. So this will be your final answer, right?